Good everyone, my name is Graphics. Today we want to study another aspect of mechanical engineering science, which is an aspect of applied physics also. We'll be looking at the topic of moment and Varignon theorem. In our previous video, when we talked about moment, we said that moment is the product of force and the perpendicular distance from the point of action to the line of action of the force, and I explained how we can apply moment. Right? Now today what we're adding towards moment now is what? The Varignon theorem. The Varignon theorem states that the sum of moment of all the forces will be equal to the moment produced by the resultant force. As we move further, we're going to explain that to you. Right? So we use the Varignon theorem to detect or to know the distance of the resultant force acting on what? On this parallel force here. Right? So let's see how we apply that. So solution. First of all, we say to calculate for resultant force. So the first thing we are going to write is the solution. Right? Now this is the solution here. So we to look for resultant force. So I'm going to put calculating for resultant. Right? That is the first question here. To find the word resultant force. Now recall, we say our resultant force. Recall, the resultant force R is equals to what? The square root of the summation of f of x all square, that is all the resultant components, plus the summation of f of y all square, that is the vertical component. Right? So this is the formula. So that means if we are to calculate resultant force, we must know the addition of all the horizontal component plus the addition of what? All the vertical components. So let's try for this first. So for summation of f of x, right, we say we equate it will be for summation of f of x. Now what are we going to do? We consider forward force to be positive and the backward force to be what? Negative. That's our condition. Right? So we move forward. Now if you look at this system here, all these vertical force are parallel to each other. There is no horizontal force. There is no force that is what? Parallel to what? To this beam. Let's call this a beam. Right? From A down here to here. Let's say it's a beam. Right? There is no parallel force here. So we say that what? The summation. That means we put this to the summation of f of x is equals to what? 0. Right? That is 1. Now we move forward and we're going to do that of what? Similarly, right, we'll look for the summation of f of y. Now we are going to consider upward force to be what? Positive, and downward force to be what? Negative. Right? So in doing that, we can say we have f of y means vertical forces, right? And we have 4 vertical force. In the vertical force, we have 2 upward force and we also have 2 downward force. The force at point A is facing upward, and because it's facing upward, we say it is what? 20 Newton. So we have 20 Newton, positive 20 Newton, plus the next one, the force at C, point C, is facing downward. Because it's facing downward, there with the arrow here, you see it says it's 100, so we'll call it minus 100 Newton. So the load is minus 100. So I'll put it in bracket because of the minus 100. Plus the next one here we see is what? 40 at point D, facing upward, so that is positive. We have plus 40, so I'll just put just 40 there, right? Plus the next one we're having here is 80, facing downward at point B. That will be minus 80 because facing downward. Now we'll say that minus 80 that we have here. Now from here we'll have it this way, that 20, right, minus times plus to give you minus, so we have 100 plus 40 minus times plus will give you minus what? 80. Now using your calculator, by adding all this all together, we're having our answer to be what? My summation of f of y will be equals to what? Minus 100 and what? 20 Newton. Right? Now we've gotten f of x to be 0, we've gotten f of y to be 0. So what we're going to do, we're going to input them into the formula here. So we'll say that therefore my resultant force, our rule, will give me the square root of, now what is my summation of f of x? Summation of f of x is what? Is 0. So I'm going to put 0 here. Why am I putting 0 here? Because at this point my f of x is 0, and there's what? Oh, we have square on it, so it will be 0 square, right? Plus the next one is plus summation of f of y, and that is giving us what? Minus 120. So I'm going to put it in the bracket to represent f of y, which is minus 120 all square. You can see that? So the f of y is minus 120, but on top of it we have a square there. Now we move forward. We know very well that my square root of 0 is what? 0. I mean the square of 0 is 0, plus the square of negative will give you positive, and the square of 120 will give me 14,400. Now this is going to give us 0 plus 14,400 will give me 14,400, right? 14,400, and that will give us 120. So we say my resultant force will give me what? 120 Newton. That will be my answer for the resultant force. Are we good? So we've calculated for the resultant force here. Now the next thing is the algebraic sum of moments. So calculating for the algebraic sum of moments now. Now I would love to do them at this side here, so we can be working with the figure we have here. Now we know that is for the next one. Let me just rule here. Now the next one will be for moment. So I'll write calculating for moment. Calculating for algebraic sum of moment. So what it means is this symbol, we want to look for this of moment. That's the symbol for it. Right? Now what we simply do, we know that moment is the force times perpendicular distance. From my previous video, part 1 of moment, talking about basic concept of moment, if you watch the video, you have a better insight of what I'm about to do here now. We know that moment, like I said earlier, is force times what? Perpendicular distance. From the point of action to the line of action of the force. So what I'll do is, I want to take a point, say from the point of action. So I'm taking, let me say my point A is my point of action, means my point A is fixed. So now I'm going to put it this way. Moment at what? Point A. Right? Now, if you like, we can put equals to what? 0 here, or we can just say moment at point A. So we want to consider, the clockwise moment coming this way to be positive, and the anti-clockwise moment coming this way to be what? Negative. All this you are seeing are the condition for equilibrium. I can come here, f of x equals to 0, that's the first condition. F of y equals to what? 0, second condition, right? And moment about the point equals to what? Also 0 here, that is the third condition. These are the three conditions necessary for what? Equilibrium. Now if you look at this very well now, I'm starting my point A. That means that point A is the point that is fixed, right? That is the point that is not moving. So if I say moment at point A, it means we know moment is force times what? Distance. So since I'm starting from point A, means my point A, the distance is what? 0. Right? So if you multiply the distance, that means anything pertaining A is 0. I don't have any business with A. So we'll start from the next point. Look at this force here. It's facing downward. Because it's facing downward, it will be going towards where? Point A. Because I said point A here, right? So anytime I'm doing, we're going towards point A. So 100 is the force times the distance. That is the distance between the force at this point to there. So what is the distance? Distance is 1. So it's coming this way. Look at, it's going in this direction. And that is what? Clockwise. So when you say clockwise, let me assume if I have my clock this way. Right? And this is 12. This is 6, 3, and 9. So anything that make me come this direction, it means I'm going clockwise. So 100 times 1, and that will give me, I'll just put it there, 100 times 1. I put it in brackets. So this is the force, and this is what? The distance. Force times distance. Plus the next one. At this point here, the arrow is facing up, so it will be going towards A. Anything I'm doing will be going towards A. So this you see here is going towards A like this. So what do you notice? Look at my clock here. Anything that is going backward this way is said to be what? Anti-clockwise. That will make it negative. So we'll say all the anti-clockwise force is what? Negative. So it will be minus 40 times distance of this point where 40 is acting to where you take moment from. So it will be from here to here is 1 plus 1, that is 2. So 40 times 2. So we have 40 times 2, but you put your negative there to show that what is negative. Now this is another force, and this is what? Another distance. Plus the next one. If you look at the next one here, right, it's coming towards this direction, and that is also clockwise towards A. So the force, which is 80 times distance of the distance from the point of action, so it will be 80 times 2 plus 1 plus 1, that is 4. So and it's going clockwise, that is positive. So we say 80 times what? 80 times 4. 80 times 4, right, equals to what? 0. Now from here, 100 times 1 is 100 plus 40 times 2 is minus 80, plus 40 times 80 times 4 is 320, right, equals to 0. Now from this point we say 100 minus 80 plus 320 will give us this, right? So minus times plus will give you minus. So 100 times minus 80 is 20. 20 plus 320 will give you what? 340. And the unit for moment is what? Newton meter. So it's equal to 0 here, right? So since this is equal to 0 and this is equal to 0, therefore my summation of moment about point A is equal to what? 340 Newton meter. That's the unit for moment. Now we've gotten the second one, which is calculated for the direction of moment. The next one is the distance of the resultant force, right? We want to know the distance of the resultant force. So what we'll do is we'll write here calculating for the distance of the resultant force, right? So now whenever you are calculating the distance of resultant force, that is when you are going to use what is called the Varignon theorem. The theorem, we use the theorem to calculate the distance of what? The resultant force from the point of the action, right? Our point of action is A, but the question is the resultant force and distance of the resultant force from where? From point A, right? So that means we are still on track. So we are using Varignon theorem. It states that Varignon theorem says that the sum of moments, right? The sum of moments, the sum of moments of all the forces will be equal. That means the sum of moment of all the forces which we calculated here, and we are talking, will be equals to what? The sum of moment of all the forces will be equal to the moment produced by the resultant force. So what is the moment produced by the resultant force? It means the resultant force times what? Times distance, d, or we can call it x. So what moment of which point? Point A. So this is the formula we are going to use, right? So I'll put recall in bracket. I'm going to put Varignon theorem. So don't forget that. So the Varignon theorem, this is what the Varignon theorem is telling about. So what's my summation of moment is 300 and what? 340, right? Equals to the reaction. The resultant force is 120. I'll be 100 and what? 120 times what? The distance. Times distance here, d. So if I divide both sides by 120, I'll be having 340 all over 120 equals to 120 times distance all over what? 120. This will equate this. So I will now say that my d will now give me what? 2.83 meters. That is my what? My distance, because we are taking moment about point A. So you can try the moment for the rest. Probably you can take moment about point B, point C, and so on. So if any point are taking moment, that is where you use at this point here. So if you have before we even go, there are some times that, let me take you down the memory lane, that the force might be inclined. Let's assume now that the force at this point here, there's another force here that is inclined here. Let me just assume. Right? Let me say the forces here. Let me call this A, B, C, D, and this is point E. You can try that on your own. Now let's say this is 30 Newton. So for you to use this, you must resolve. So you assume this force coming this way. Probably they gave you an angle of what? 60 degree, right? So here will give me 30 cos 60. Here will give me 30 sine 60. So you know that when you are dealing with vertical components now, you consider this. That means if you are looking for f of y, to be 20 plus 20 minus 100 plus 40 plus what? 300 sine 60. Then minus 80. That will be all what you use for the what? Summation of f of y. Right? Then for the summation of f of x, what you are going to use will be only 30 cos 60. So your f of x now will no longer be what? 0 here. It will be 30 cos 60. Is that taken? So in case you see questions like that, you just have to resolve it and you continue working. So if this video has been helpful to you, please don't forget to what? Click on the subscribe button and share with those who you know can benefit from it. Bye.